Welcome to DBL Talks. My name is Mike. Joining me today is Daniel. We're interns here at Synergex, and we're very excited to bring you the second rendition of DBL Talks. We also want to give a large shout out to Elaine. She's another intern here at Synergex, and she helped a ton with this episode. And if it wasn't for her help, this episode would have never came together.
That's right. And for this second episode, we want to look at the select class in Synergy DBL, which is a very powerful, essential feature that you can use right now to bring SQL-like querying to your programs. And with that, this first segment that we're going to be looking at is to look at the from object, which is an essential part of the select operation. And with that in mind, let's just dive right in.
Yeah, let's get to the example.
To kick off this example, we must first import the select class that we're going to be using, and we've already done so. We also want to set up our data record. In this case, I've already done so as well for the employee record, where it's very simple. It's just employee ID, first, last name, the department, and salary. Now, for housekeeping's sake, we also want to set up a new record that we can also where we will define our channel and our class objects that we'll be using. In this case, it's just very simple, just a channel on an I4 and a from object. Now, when you're making calls different to using the select class, you obviously want to be making that against an ISAM file. So let's go ahead and open that file up right here. It's very simple, just an open. We're opening on a channel. In this case, it's going to be channel 0. We're going to be opening this guy up in mode II, and obviously the file name, so employee.isam.
If you don't mind me asking, what does II do in the open call?
It's very simple. II opens an input from the employee ISAM onto channel 0.
Follow-up question, what does the from object do in the record?
Yeah, another good question. In essence, it acts as the binding link between your program's data area and the data source. It's really the first step in constructing a select query. Now let's move on. Now that we've opened the file, we also want to create a from object from the employee file. So in this case, we're gonna paste this line in where we define what the from object is, as I explained. What that means is that every time we retrieve a record, Synergy DBL will populate employee record with the data from the file. Keep in mind, however, that the employee record data must stay in scope the entire time the from object exists. If it goes out of scope for any amount of time, the binding breaks and you'll run into some problems.
All right, so for the second segment, we're going to be covering the where and the select clause. The best way to think about what these are is the where clause that you specify the data you would like to pull, while select kind of just ties the from object, which we just handled, and now the new where object, and it combines both so we can iterate and actually grab this data and use it. So to start off this example, we are going to need to update the record over here. So let's update this really quick. So I've had here a where object with type where and a select object of type select, which is going to be needed to use these new objects. And in the meantime, I'll also grab the where object and toss it in. So this is actually quite simple. So we're setting up a where object of type where, and I'm grabbing the employee record with the field of department, and I'm setting it to software. So in essence, you can think about it, I'm just grabbing all fields with software matching. And
so OrderBy doesn't care if the field is indexed?
Yeah, that's a good question. If you wanted to add additional conditions, you can either use a double ampersand, as in this. So we can do, for example, maybe employee record with salary that is greater than 100,000. Or you can do the same exact operation with dot and dot. To continue on, to tie this together, we're going to need to grab our select object. All right, so with the select object, let's go down to my notes here. So the idea is we're first passing in a from object. That is our binding to our data source. And then we're also adding in a where object. This is basically our filter. We're just selecting employees in this instance from software with a salary greater than 100,000. And a very simple pattern that's going to be very common when you are iterating using select operations is going to be a for each loop. So again, just like previously, I've been copying. I'm going to toss this in, and also accounting for closing the channel at the end. This may look like a lot. It's quite simple. I'm grabbing here employee record for each select object, and I'm iterating. And I'm just going to be printing out the first name, last name, department, and salary. And to tie this all together, let's go to the example. Here it is. Let me just grab So quick DBL, DB-Link, and DBS. Okay, great. As you can see, I got here a list of a lot of employees, their ID, first name, last name, department, and their salary. And you can see all of their salaries are all greater than 100,000. And I could prove that point if I was to get rid of this additional condition, close it out, and I reran this. You can see here I have a lot more options and the numbers are very, very far apart. With that in mind, that closes out the select and the where clause segment, and we'll be moving on.
Okay, in this segment of the episode, we're just going to do a very simple and very powerful operation known as the delete operation. In this example, let's just go over what we've already written, just so you're caught up. We've already set up our employee record, our channel, from object, where, and select object. And the only real change I'm going to make is going to, because we're going to be showing off the delete operation, it's a modifying change, not an inserting change. We're going to change from II mode to UI to update mode, obviously. We're now also going to delete this from the old example. And just to show off the power of delete operation, let's say we want to delete everyone from, there we go, from the HR department. That makes more than $50,000 a year. And I'm also going to add this line, which not only does the delete operation itself, it also points out how many of those records it deleted that matched our where clause. So let's go ahead and save. And if all goes well, let's go ahead and run this. I already have our DBL, DBL-Link, and DBS, and fantastic. It says it deleted those 123 of these employees. And let's run it one more time just to show that it actually deleted them. So now if the second time that we ran it, notice how it says there's 0 employees. If you couldn't already tell, it says that because from the first time we ran it, it deleted those records. So the second time we ran it ran the same where clause, HR department, more than $50,000, and it didn't find anything because they got deleted, obviously. So that's it, very simple. Let's move on to the next segment.
All right, so far we've seen how simple it is to use select operations. To continue, we're going to be covering OrderBy. OrderBy is very similar to SQL's OrderBy. There's only one idea to keep in mind is that OrderBy sending and descending lets you sort by fields that you choose, but the sorting does happen after the full result set, so it may be slow for larger data sets as it is sorted in memory. One also idea to keep in mind is you can also chain multiple order bys with and double ampersand as we've shown in the where object.
So OrderBy doesn't care if the field is indexed?
Yeah, exactly. It sorts everything in memory. Just remember OrderBy is case sensitive for alpha fields, so use no case OrderBy if you want a case insensitive sort. Also, OrderBy and GroupBy can't be combined in the same select. So to continue this example, let's just quickly show the power of OrderBy here. I'm just going to copy and paste this over from my example fields. All right, so here at the end, I've appended OrderBy.ascending for employee record salary. As you can imagine, I'm going to be ordering the output in ascending by employee records with the salary field. And just to display this, just quickly jump over here. And as you can see here, I got the large salary starting at the bottom with the smaller salaries towards the top. And it's also going to be vice versa if I did descending here. So let's just show that off. So why not? And as you can see, the opposite is also true. With this in mind as well, you can also use this on string fields such as first name. And you're going to see here I should start with A's towards the bottom, as I do, with Z's towards the top. Zachary ending it off.
All right, now that we've covered filtering and sorting, let's look at GroupBy, a very powerful feature which you don't want to miss. Just like SQL's GroupBy, it groups records by shared values. For example, grouping by departments will collapse all employees, for example, let's say in the software department, into a single representative group.
Just to ask, so it only shows one record per group?
Yeah, GroupBy returns just the first record for each unique value. Also, one thing to remember is that it uses a static cursor, meaning that the result set is fixed when you start iterating. Any changes to the file afterwards won't appear in the grouped result. So the change itself to change over from our last example is very simple. We're going to change over from update mode to input mode. And we're going to copy over this new example where we use a sparse along with the group.
Why do we need sparse with GroupBy?
That's a good question. Whenever you use GroupBy, you must include sparse along with it, or we get an error. What sparse itself does is it specifies which fields to keep and which to ignore in memory. So in this example, what we're doing is we're going to use an asterisk to say that we want all the fields. So let me just do an example. I think it's easier to show than to tell. So let's run the field, and as you see, looks like, oh, a rookie mistake, we didn't save the file. There we go. So as you see, we have all the departments. So we still have just the first record from each department, but let's say that we don't want all the different values, the first and last. So let's say we just want the department. What we can do is we can change this to employee record. Let's say dot department, save, run, and as you see, we just return the department. So very simple and very powerful feature. Okay, let's now take grouping just a step further. We're not only going to be grouping by the department, we're also going to be grouping by the total number of employees from the department, the average salary, and the total salary from that department. What we're going to be using for that is going to be this special new program that we made. It looks a little complicated, and you're going to find it in the description of this video. And along with the other files for this episode, we recommend that you download them and then you play around with them to your liking. So what this file does is you'll notice there are multiple from objects and different channels. What these do is they run two different aggregation passes. The outer pass iterates over each department group, while the inner pass rescans that department to compute the totals and averages. So very simple in concept. It looks complicated, but it really isn't.
Just to ask, so the second record is just for calculating the sums and averages?
Yeah, exactly. It keeps the grouping logic separate while still letting us aggregate the data that we need. The from object here, right here, the first one drives the grouping pass, and the from object 2, what it does is it's dedicated to the aggregation pass from the inside, so we don't disturb the outer enumerator. This is the same line that we saw earlier where GroupBy will return only one row per department, where we could also blank out the values from all the other fields. The FOREACH here itself is very simple. Once again, it iterates one representative group per department because of GroupBy, obviously, and you can also think of it as the FOREACH department do this. In this case, we're going to be grouping by the average and total salaries. Very simple. All right, very simple. Let's just go ahead and run this. All right, as you see, we are doing exactly what we need. Notice how the HR department from earlier where we updated it so that it deleted all the employees from HR department, we had a salary of over $50,000. Now you can see the average salary is a very nice around $45,000. Alternatively, what you can also do is you notice how we have an unused where object. You can also add as many parameters to this select cause as you want. In this case, so let's just add it to the end right here. In this case, we're not going to be grouping for all the departments that we have. We're just going to be grouping for the departments whose name is software. All right, let's save and run this again. And as you see, just as the software department had 60 people, that's the only department that we're iterating over here. Now, with that in mind, let's go over to our next segment where Mike will look over joins.
All right, in this part of the episode, we're going to be covering joins in Synergy DBL. Specifically inner join and left join. These let us combine data from multiple ISAMs, similar to how you would use it in SQL joins. So with that in mind, we're going to be building off the original iteration example we had in the beginning. And to make this work, we are using another record, which is called department record, for naturally joins to work. So with that, let me just quickly copy and paste that in to view for you guys. So with department record, we have a name, a first and last name, including a location and a budget. And in addition to that, we're also going to be updating the housekeeping record. So just follow along here. So we're going to have two channels. Naturally, you got to cover both ISAMs, both department ISAM and employee ISAM. So we have two channels here. We're going to have two from objects. You got to handle both ISAMs. And in addition to that, we have a row object, and this just allows us to iterate over the rows so we can show output for both ISAMs. And there's going to be also one additional change. We're going to have a slightly different select object. Instead of just a type of select, we have a type of join select. This accounts for using joins functions. With that in mind, we also got to open up both ISAMs. So let me just bring those over into view. So here I'm opening up a channel for both employee ISAM and department ISAM. And following along that pattern, I have two different objects, a from employee object and a from department object. And this is where I'm going to toss in as well join select object. So to explain this, we're making a new select. I'm grabbing the object of from employee, and I'm going to do an inner join to the from department. And we're going to be matching up the employee record department to the department record department name, which is a bit of a mouthful, but basically just linking both records together.
Hold on, so if we're matching a department name, what happens if an employee's department field is blank or doesn't even exist in the department file? Does inner join just skip them entirely?
Yeah, exactly. With an inner join, there's no matching department record, or if the department name is missing, that employee won't appear in the results. With that in mind, let's iterate it over a FOREACH loop so we can actually show this functionality. So let me grab this over. It's going to seem like a lot, but trust me, it's not too bad. It's a very common pattern you've already seen before. So we're going to be iterating over a row of object in the join select object, and we're just going to be filling out so we can get outputs for both. And same thing last time, we got a console.writeOut with employee ID, first name and last name for the employee record, and a manager first and last name along with the location for the department record. And it's also a good thing to keep in mind, you got to close out both channels. We did open up, so let me close those out for both different records, and let us see the output here. So I'm going to output out. You're going to notice we did skip over the first two IDs, and I'm going to explain that a bit later, but what it comes down to is that the employee records first two IDs are missing their department field, which is why inner joins skips over them. So as you see here, we have both the employee record and the department records outputs joined together. And just to show off that left join functionality here, we're gonna quickly just adjust this to left join, save it over, and you're gonna see if I do the exact same output, which I'm just grabbing the top 5 rows, you're going to see I see now finally ID 1 and 2 appear into view, and you're going to see that the department manager and the department location are omitted, and that's because there is no binding link between the two records, as the employee records field for department is missing. With that in mind, let's get to the recap. So inner joins only includes records with matching keys in both files, while left join includes all records from the left file, even if there's no matching file on the right side. Yeah, with that, that's going to cover joins, and we're going to head over to the next segment.
We thank you once again for tuning in on this episode of DBL Talks. We covered a lot in this episode. If you want to look at the source files that we worked on in this episode, you can find them in the description. And if you have any more questions, you can always look in the DBL book, and you can find a lot more information in the documentation that we have. Yeah, that's it.
Yeah, thank you for watching this episode of DBL Talks. Please do look around the channel for additional information and content, and we'll see you in the next episode.